Alright, so let's try that again. Gave you guys a circle yesterday. I'll draw a better circle too. And we had some lines inside of that circle. And I told you like this was 100 and this was 50 and you're trying to solve for x and y. So two main things. If a circle is cut in half, you can figure out one half of the circle, then you can find the other half of the circle. So how do you know if a circle is cut in half? What was that special word that started with a D yesterday? So this line right here is a diameter because it goes through the center of the circle. So that means if you just look at this half of the circle, that half of the circle has to have half the degrees in the circle, or 180 degrees. So if this pie slice is 100, how big is that one? 80. So now I know for a fact that this half of the circle has 180 degrees on it, because this line is a diameter. Now I can look at this one. How big is y? 130. Now, not drawn to scale. So there is 360 degrees in the circle. And yesterday we looked at the degree measurements going with that. Now today how it's going to change is I'm going to ask you to find the length of this line right here. Like how long is that line in a numerical value? Like 10 inches, 12 inches, 13 inches. Alright? So we're going to kind of double do both tasks today. We're only using one formula, guys. This formula is the same for today as it is for next week. So the book says that you can find the length of an arc by doing the measure of the arc over 360 and multiplying by 2 pi r. That's the book way. Allow me to show you Baker's method. Are you ready? So Baker's method says, arc length over circumference is equal to degrees over total degrees. So it's a proportion. So it's part of the circle over the length of the whole circle, and it's the amount of degrees you have over the total number of degrees that there are. So I can show you how this equation on the red one looks like the black one if I use the black notation. It would be the arc length of AB over the circumference is equal to the measure of the arc over 360. So that is length over length, degrees over degrees, and you can cross multiply and solve. That, I know you're scared of that, but when we look at the first problem, we'll be like, oh, that's all I have to do, and it'll be nice for us. Okay? Now we're going to leave all of our answers in terms of pi today. It's going to make all of our answers nice and pretty and nothing super crazy. Alright, so have this somewhere where you can see it or memorize it, one of the two. And here's what the problems look like. It says, what is the length of the darkened arc? Leave your answer in terms of pi. So remember, we're trying to do arc length of AB over the circumference equals the measure of arc AB over 360. So just kind of fill out what we know. Do we know how long in meters this darkened arc is? No, that's going to be our x value. Can we figure out circumference? 2 pi in the radius. 15. 2 pi r. 2 pi 15 is the circumference. 2 pi r. Now we need to figure out how many degrees is this arc. So if this piece right here is 60, what's left over for the other side? 300. over 360. Gives me 300 degrees that I'm trying to solve for, and there is a total of 360 degrees in the circle. So I can do one small step to make it look a little nicer, and you could probably do this in your head, but I like to write it down. I can multiply 2 times 15 and get 30 pi. And then it's just like every other proportion you've done. Cross multiply and solve. So 300 times 30 pi. Well, 3 times 3 is 9 with 3 zeros. And a pi. You don't multiply by the pi. Equals x times 360. 360x. And how do you get x by itself? Divide by 360. Now here's where your calculator is amazing. You have to simplify that. So you can go to your calculator while mine loads and type in 900 over 360. And it should give you a simplified fraction, or 9,000 over 360. I don't know if you can put the pi in there or not. Does it work both ways? Huh? There's 20, like straight up just 25? I do control divided by and do 9,000 over 360, and it gives me 25. Remember that there's a pi in there. There is a pi right here, so we have to keep the pi on the top. So the arc length from A to B is 25 pi. Does that kind of make sense? So if this length is 25 pi's and the whole circle is 30 pi's, how big is this piece? 5 pi's. And I could show you that if we wanted to solve for that, x over 30 pi should be equal to 60 over 360. I can cross multiply. I'll show you how to do this in one step. So I do 60 times 30 divided by 360. 60 times 30 divided by 360. 5. So you can do it all in one step. 5 pi's is the length of the other side. So today we're solving for how long around is the arc. It kind of makes sense? Is the pi scaring you guys? Kind of a little bit. It's just kind of like a variable that's just going to stick with it. You're not going to use it to multiply it out. Alright, so we're going to use this same question for the next 3. Alright, so be vigilant at what we're solving for. We're solving for VT. Arc VT. That is, right now, this piece right here. So, can I immediately solve for it, or do I have to do a little bit of work on the picture to figure out what's going on? You gotta do a little bit of work. right? This line, ST, is a diameter. So if this little piece right here is 30, how big is the other piece? How big is this half of the circle? 180. Half of a circle is 180. So if half of the circle is 180 and I already have 30 degrees spoken for, what's left over for this piece? This piece is 150. So 30 and 150 make 180 on this half of the circle. This piece is 90, so this piece has to be 90. That's good to know. I know every degree measure for all the parts of the circle. So now as I go to solve for other pieces, I don't have to repeat my work. Now I'm trying to solve for VT, and we're using arc length over circumference equals degrees over 360. So how long is VT? How long is VT in units, in centimeters? In centimeters. We don't know. That's what we're trying to solve for. That's going to be our x. What is the circumference around the circle? 2 pi r. And what's our radius in this circle? 5. So that's some unknown length over a length we do know, the circumference of the circle. And that should be equal to the number of degrees VT is. How many degrees is VT? 150. Over the total number of degrees in the circle. 360. So you can do one cleanup step. X over 10 pi equals 150 over 360. Cross multiply. 10 times 150 pi. Or 10 pi times 150. What's 10 times 150? With the pi. All right, 150 times 10 is 1500 with a pi. Multiply the other way. X times 360 is 360x. We're trying to solve for x. So we want to divide by the number next to x. So we want to divide by 360. We got to do 1500 over 360. Don't use the pi. That's just a variable we're going to leave. Control divide 1500 over 360. 25 over 6. 25 over 6. That's our answer. Where does the pi go? On top or on bottom? On top. $25 pi over 6, which is like 6.25 pies. We want to leave it as a fraction. 6.25 pies. So your calculator does a lot of work for you. All right, let's try the next one over. Let's copy my work down. I already figured out this is 150, this is 90, and I know that this piece is 25 pi over 6. So this question is asking me to solve for UV, which is from here to here. Do I know how long that arc is? No, that's what I'm trying to solve for. So the length of the arc over the length of the whole circle. Baker, wait, we already did that. What is the circumference of the circle? 10 pies. Because we did that in the last problem, right? Now, how many degrees describe arc VU? 90 and 30, which is a total of 120. How many degrees are in the whole circle? 360. So grabbing small pieces to build our formula, that's the small length over the whole length, the small number of degrees over the whole number of degrees. And we're going to cross multiply. 10 pi times 120 is 1200 with a pi. X times 360 is 360 x. What do we divide by? Divide by 360. Ten pi over 3. 10 pi over 3. Arc U V equals 10 pi over 3. So we leave the pi on top, even though we're simplifying this fraction. So this piece is 10 pi over 3, or 20 pi over 6. So if I wanted to math a little bit, let me make sure I don't ruin anything. If I wanted to math a little bit, the whole circle is 10 pi's, right? 10 pi's? Or the whole circle is 60 pi over 6. That's the same thing as 10. I can take away 25 pi over 6, I already used that. And I can take away 20 pi's over 6, I already used that. So if I add these two together, I get 45 pi's. What's 60 pi's minus 45 pi's? That means that this piece right here would be 15 pi over 6. I can use subtraction. So if I add all those pi's up, 15 pi's, 20 pi's, and 25 pi's, I get 60 pi over 6, which is 10 pi total. So now I can just use a little bit of subtraction to find that missing piece. Well, the next question is going to ask us for this piece right here. Can I just add 15 pi over 6 and 25 pi over 6 and get 40 pi over 6? Right, that's how long that arc's going to be, 40 pi over 6. Then we can double check our math to make sure it works. So we're guessing that this length from here to here, U, T, V, is 40 pi over 6. We have this information that we already discovered earlier, and we're just double checking to see if that answer is correct. So if we're going to solve for UTV, we're going to do x over the circumference of the circle, which we discovered earlier was 10 pi. Then the number of degrees that describe UTV. 240 degrees. Over the number of degrees of the whole circle. So we cross multiply. 240 times 10 is 4 with 2 zeros and a pi. 2,400 pi. We divide both sides by 360. So 2400, oops. $20 pi over 3, if you double both of those numbers, what do you get? 40 pi over 6, which is the number that we got earlier. So the simplified version is 20 pi over 6. It's kind of a crummy example because they're all like really nasty fractions, but oops, sorry. 20 pi over 3. Sorry. This is my favorite part of the year. Because I get to start telling you guys time in degrees instead of minutes. So right now you guys have about 180 degrees left in class. And you're like, what? I have to do math to figure out what time it is. So it says, how far does the tip of a minute hand on a clock travel in minutes if the distance from the center to the tip is 9 centimeters? Leave your answer in terms of pi. Yeah? What? So you have a clock, and you have to break your clock down into increments. 12, 6, 3, 9, and you go like, you start counting pieces. 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6, 7, 8, 9, 10, 11. Alright, if you get confused, you can always just look on the back wall of the clock that's back there. So, how many chunks do we have? How many chunks are on that clock? There's 12 chunks on the clock. And they're all equal. Otherwise, time would not make sense. Okay, right? They all have to be equal distances. Otherwise, time wouldn't work. So, if I have 12 chunks, how big is each chunk? How many degrees are in a circle? Divided by 12 equal chunks. So each chunk is 30 degrees. That means if the center of my clock is here, 30 degrees, 30 degrees, 30 degrees, 30 degrees. So if the minute hand travels for 20 minutes, that's 5, 10, 15, 20 minutes. How many degrees does that minute hand travel? $120 degrees. From here to here is 120 degrees. So 20 minutes is 120 degrees on the clock. Well, I want to know if that clock hand is traveling 120 degrees, what is the distance that the tip of the hand of the clock is traveling? So, do I know how long the clock hand is? 9 centimeters. That becomes the radius of my triangle. The radius of my circle. 9 centimeters. So this length or distance is undescribed. I don't know how long that is, x. But I do know the circumference of the circle. 2 pi r. And what is my r? 9. So that's the length that the tip of the clock is traveling over the total length that it's going to go around in one circle. Well, how many degrees is 20 minutes? 120. How many degrees are in the clock total? 360 degrees in a circle. So this is the length that the tip of the hand will travel from here to here. I don't know how far that is over the whole length of the circle. I can figure that out. 2 pi r. The number of degrees that is equivalent to 20 minutes, 120 degrees, over the total number of degrees in the circle, which is 360. So I cross multiple. Sorry. What's 9 times 2? So it's going to be a little more complicated. 120 times 18. $2,160 with a pi next to it now. So when I cross multiply this way, I get 2,160 pi. When I cross multiply this way, you get 360x. Divide both sides by 360. We can use our calculator. Control divide 2,160 divided by 360. 6 pi. So this simplifies down to 6, and we leave our pi there. So it's 6 pi centimeters, which is like 18 centimeters, guys. 18 centimeters to go 20 minutes in the clock. Yeah? Maybe. Here's the last thing that I want to just briefly touch on. Is what if we have to do algebra to solve for degree measures? You're welcome. Man, I love this class. So, you're like, oh, algebra, no. This is, what do you call this thing right here? A diameter. So how many degrees is this half of the circle? 180. So this piece and this piece add up to 180 degrees. Huh? Does that make sense? So like this is a diameter. It cuts the circle in half. So that means that this piece is 180 degrees and this piece is 180 degrees. Now I just say that the first chunk plus the second chunk, they have to add up to 182. And I can just kind of combine like terms. 1a plus 2a's is 3a's. And then 24 is by itself. Subtract 24 from both sides. And divide both sides by 3. So I'll do that with a calculator. 204 divided by 3, 68. So A equals 68. And you're done. Just kind of using that like degree measure philosophy to apply some algebra for this one. Cool? All right.